Hi, welcome to my next video on the United Manufacturing Hub. In the last video, we created a flow in Node-RED that queried sensor data from a sensor and saved this data in a Kafka topic. The topic of this video will be how we can make sure that this data is stored long-term. And for this, the video will consist in 4 parts. In the first part, we will look at a data historian, which will be just commonly used in manufacturing for this kind of objectives. The second part of the video will explain how the data goes from Kafka into the historian. The third part will look at the data model, so it will highlight in which format and is data written and how it's organized in the historian. And finally, we will look at the example from the previous video and explore how this data is saved in the historian and how we can query it using dbeaver. The first topic is about how data is commonly stored long-term in manufacturing, and for this we commonly use data historians, which are essentially databases that are optimized for storing time series data. And the one which is provided automatically inside the EMH is called TimescaleDB. And I personally like this a lot because TimescaleDB is in essence just a Postgres database with some additional capabilities for working with time series data. So everything you know about relational databases still applies to this particular historian, which is open source. Now, let us look at the way the connection from Kafka to TimescaleDB is configured. And the good thing is it's actually completely configured for us. We don't really have to do anything special to get the data from Kafka into TimescaleDB, and this happens automatically. We will see in a moment how exactly this works. In this page of the documentation, I explain how the Kafka to PostgreSQL service works. This service is the one that automatically writes data from Kafka to Postgres. And I don't want to go into too much detail here, but I still want to highlight one important feature, that essentially there is 2 paths or 2 ways in which data from Kafka can get into Postgres. And this path depends on the topic itself and essentially on what the data looks like, and there's a reason to it. So this service consists of 2 Kafka consumers. One is used for high integrity topics, and the other one is used for high throughput topics. High integrity topics are topics which contain data that's absolutely essential to capture in manufacturing. This is data mostly coming from, the way I see it, level 3 or the MES, and relates to production. Examples are, hey, I'm producing this product on this machine, I'm starting my production now, so the state of the machine is on, it's currently being performed by this shift. So really production data. And you don't want to lose this, because if you lose information about an order, then you can no longer map all the process data from this order, right? The second Kafka consumer is used for the high throughput topics. This is really the inverse case from the high integrity consumer. I should add that the high integrity consumer, the way it works is that it waits. So the Kafka to Postgres service waits for a feedback from TimescaleDB that, okay, I have received your event and I've written it to the database, which is why it's a bit slower. It's slow, but it's guaranteed. The high throughput Kafka consumer works differently. It doesn't wait for a feedback. It just writes the data as fast as it can. And as you can probably imagine, this is very relevant for level 2 data coming from SCADA. So this is really all of your time series. your temperature values, your current values, pressures, and so on, that can come at a frequency of seconds or even milliseconds. So you have a lot of data coming at a very high speed to TimescaleDB. And this is why we have a connector which says high throughput. It works and writes really fast, but it does not guarantee that each and every millisecond lands in the database. It's not really a big deal anyway, because if you have data in millisecond frequency, it's really not that much of a problem to lose a couple of values. Alright, so now that we know that we use TimescaleDB, we know that we have the Kafka to Postgres SQL service that writes the data either via the high throughput or via the high integrity Kafka listener. Let's now look of how we can actually, of what the data model looks like in TimescaleDB. And a question that may come up at this point is that, yeah, but how does the service know from which topics to write the data into the database, and how does it know into which table to write it? And this is why we land now at the topic of the data model, because there's a very clever mechanism that relies on names, on the names of the topics to decide in, first of all, which connector to use, and also into which table to write this data. Essentially, the data model consists of three, but I would say really two types of data. The first, you have the raw data, which is not processed by the UMH stack at all. So this can be used, for example, for your own applications. It will be written to Kafka, but the connector, the Kafka to Postgres connector will essentially ignore this data. The second type of data, or the first one, which is really useful in my opinion, is the process value data. So again, level 2, think about process data, temperature, physical parameters, and so on, high throughput, right? And the third type will be the production data. This is level 3, MES data. It has to do with, for example, adding a new product, adding a new production order, signaling the start of the order, the end of the order, and the state of the machine. Now, you have a bunch of documentation here relating to all the kinds of messages that you can send. And each of these messages will have to land in the topic that has the name of this message in its name. What do I mean by this? It's probably more clear if we look back at our result from the previous video, where we have defined a flow in Node-RED. And if you remember, I gave the flow a very particular name. I began by saying it's the client factory inside, in the location in Hamburg. The asset was our melting furnace, and the value that I'm writing is a process value / humidity, because it's a humidity sensor. But the process value is really key, because this part of the name will tell the Kafka to Postgres service that this is in fact a process value type in the data model. And therefore it will know that it has to write this data to the process value table using the high throughput Kafka consumer. So the name of the game is really to look at the name of your Kafka topic. So if, for example, you are collecting information about orders, you would add it, for example, in a Kafka topic which has add order or start order or end order in its name. And those will be automatically written to the correct table in the TimescaleDB database. Right, to make this a bit more concrete, in the next part of the video, we will look at an example of how this works for our flow in Node-RED. Alright, so in the previous three parts of the video, we defined first what is TimescaleDB and how it's used as our data historian. We then looked at the Kafka to PostgreSQL service that writes the data from Kafka into TimescaleDB. And finally, we looked at the data model that enables this automatic writing from Kafka topics into Timescale database tables using the name of the Kafka topics. Now, to make this a bit more concrete, let's now look at an example from our previous videos, Node-RED flow, to see how this data now actually looks like in a table. As you remember, we had the key name here, processValue. So by writing the processValue here in the Kafka topics name, the messages from this topic should be written to the processValue table. As to remind you, the message looked like this. We had a timestamp in milliseconds as an integer, and we had the name of the process value, in this case humidity, as a key, which will be a float. If you look at the schema for this process value table in the database, it looks like this. So we have a certain timestamp, an asset ID, which will in this case should be our melting furnace, right? The value name will be the humidity, and the value will be the actual floating point. There's a relationship between the process value table and the asset table, because over the asset ID, we can actually retrieve more information about this asset, such as the customer where it's installed at, and the location of the plant where this asset is running. Now let's look at the data in the database itself. Remember, TimescaleDB is essentially a Postgres database, which means we can use any common database GUI tool to query this data. Now, I personally like to use dbeaver, so I've configured a connection to the database that looks like this. The host will be, in my case, just Flatcar, because this is DNS resolved to the IP address in my virtual machine. If you want to set it up like this, you can watch my previous videos on configuring a static IP for Flatcar. The database will be the client's name. In this case, the client will be the default client used as an example in the UMH, which is Factory Insight. And to authenticate, we use the username and password, which can be obtained from the secrets in OpenLens. So that's configured. We can connect to the database. And let's look at the databases we have. So we have the Factory Insight client database, where we have the following tables in the schema. We have the asset table, the component table, order table, and so on. Let's take a look at the assets table. So if I view the data from this table, we get an overview of our machines we have at this particular client. So we have a couple in Berlin, but the one we care about is the melting furnace we have in Hamburg. Let's take a look at the table that interests us the most, which will be the process value table. Remember our Kafka topic, process value.humidity, should be written to this table automatically based on the name. If we look at this table at the data in this process value table, let's view the data here. We're going to see indeed that it has the structure as defined in the documentation. We have the timestamp, the asset ID, the value name, and the value. Now, to actually look at the humidity data, I have written a SQL query earlier that shows us, that queries this data. Essentially, what I'm doing is I'm querying the timestamp and the customer location, value name, and value from the process value table, on which I have joined the asset table on the asset ID. That will remind you. So I'm just making use of this relationship between the two tables. Now, if I execute this query, we see that indeed we have our timestamp for the customer Factory Insight, location in Hamburg. For our melting furnace, we have our humidity values as floating points. This is to show you that we can query the data easily with dbeaver. Of course, in real applications, we want to consume this data in different ways. And the UMH by default provides two convenient ways to extract this data from TimescaleDB. The first one is by using Grafana. We can connect easily and explore the data from TimescaleDB in Grafana to create, for instance, dashboards and visualize the data. A second way, if you want to obtain the data more programmatically, let's say you have an application that runs somewhere that wants to consume this data. Well, for this we have a custom-made component called Factory Insight, which allows you to query this data from TimescaleDB via a RESTful API. But those are two topics for future videos. So as a recap, in this video we did 4 steps. In the first part, we defined data historians, what they are, and that the TimescaleDB is used as a data historian in the United Manufacturing Hub. In the second part, we looked at the Kafka to PostgreSQL service that copied the data from Kafka via 2 ways, either high throughput or high integrity. In the third part, we looked at the data model that enables the automatic writing from Kafka to PostgreSQL or to TimescaleDB based on the name of the Kafka topic. And finally, we looked at an example that built on our Node-RED flow in the previous video, where we showed through a simple query that indeed we can retrieve the data from Kafka to in our TimescaleDB database.